Okay, so this we said if you want to fit the model after extracting all that you need, remember we said we need the number of deaths, the number of deaths we need the exposure, which is the initial exposure, which we said you can get it from the the central exposure plus 0.5 times the number of deaths, and then the ages, we can also extract that, the years we can also extract that, and then the age groups that we want to fit the model for, and the weights that we want to use. So all that will be the argument you supply to the fit model or the fit function. So when we run that, you can see that we are fitting. So I think it is done. Finish fitting with GNN. So the model has been fitted. We can look at the summary of the model, and it tells us that, looking at the summary of the model, tells us that we have the estimate. The AX has been estimated, there are about 35 of them. The BX has been estimated, we have about 35 of them. The KT, about 51 of them. So the AX are the estimate or the average. When we take the log of them, you sum all the log of the mortality rate or the rate for all the various years for a particular S age group, and you divide by the length of time. That will be the AX for that age group. So this is done for all the various age groups. So there are about 35 age groups here, so we should get 35 AX, same as the BX, which is also a multiplier of the KT, where the KT is also talking about the trend in the mortality rate. So the KT captures the trend in the mortality rate. Okay, in the BX, just like the coefficient or that thing that combines or try and then force the effect of the age groups on the trend, which is a BX. So we also have 35 of them because each age group also gets BX for them. Okay, so we have estimated them. So let's see them. Let's see those estimates. We can look at it from here. We can call the function and then use $sign to get the estimate. So we need to see the AX. So when we run it, we can also see the AX. So we have all the AX for the various age groups, and these are negatives because we are kind of summing the log of the mortality rate across that all the years and dividing by the length of the year for a particular age group. So age group 55, you can see that the AX is negative 4.724524. Okay, so that has been done for all of them. And then from literature, when you sum all the AX, the value you should get has not been stated, but you can look at how the sum of it is not very necessary. So you can look at the sum, it's around negative 404.935, which is okay, it's not bad, it doesn't really tell us anything interesting. Let's look at the BX. You can also extract your BX. So these are the BX, which are the coefficient or the multiplier of the KT. So the KT, the trend component, is influenced by the KT. Okay, so it kind of if the value of BX changes, it's kind of influence or affect the trend. Okay, and it happens that the sum of it in literature, the sum of all the BX in literature is supposed to converge to 1. So let's see if that is true. So that here is true. Okay, and then look at the KTs too. You can also look at the KTs for all of them. Remember, we said the KTs are computed with the time, which is the years here, 1960. So it's like a trend thing. In fact, it is a time series. The KT is a time series. So KT is actually KT minus 1 plus some error component. Okay, so KT is a time series. So these values here you see here are time series data set. It captures the trend in the mortality rate. How is the mortality rate changing over time? Okay, that is what it's capturing. And then the sum of it is supposed to be somewhere 0. So when you sum, we are getting something negative 3.16 something, which is somewhere approximately 0. You can see that it's approximately 0. And then we can plot all the estimates that we got with the line 57. Okay, so plotting that to, we can see it's shown in our plot section. All right, so you can look at what the AX is just the average over all the age groups, and you can see that the average is somehow increasing. The average is somehow increasing from 55 to 90. And you can look at the BX. The BX is also decreasing from the start of the year and going down. Same as, so look at the trend component. It's a downward trend. So it tells you some way somehow that, yeah, in future the death rate is kind of going to decline or go down, which you can somewhere attribute it to. You can attribute it to maybe an increase in healthcare or something else, some uh, yeah, enhancement in medicinal stuff studies. People are just getting into stuff, so a lot of technology, a lot of medicine, a lot of vaccines are out there, so people are less likely to die or something. So that is the trend that we have there. Okay, now if you also want to see the residuals, you want to see the residuals of the model. Every fitted model has a predicted value and then the exact value. So you want to see the difference between them, you can pass the object, which is the fitted model, into the residual function, and then you can get your plot or your residuals to them. So you can view your residuals and see, so kind of these are the residuals. You can see them, some are negative, some are positive, so that is also something you can also get. You can as well plot the residuals. Okay, so you can plot the residuals and also see what is going to happen. So this is like a plot of the residuals, and then across the age group, across the calendar year, and then year of birth. So calendar year, you should be aware that's the exact years we are working with. The year of birth is the year of birth of each of the exact calendar years we are using here. So if somebody is at 1960, the person is like 55 years old, then when was the person born? So we have to go back there and see that date, and also do that also with it. So this is the scatter plot of the residuals, and it looks nice, not so bad. So your model is in fact doing well. So now that you have such a model, you can go ahead and forecast, go ahead and predict, maybe in the next 10 years, in the next 20 years, the next 40 years, what is going to happen. And you can pass that using the forecast. Okay, so using the forecast, you can set age. Age will be the how many years, in how many years time do you want to forecast. So let's say I want to forecast for the next 10 years, or I want to forecast for the next 15 years. And you pass in the model, use a forecast, and you pass in the model, you run that, you have done the forecasting. If forecast, you want to look at the rates, what are the mortality rate for the forecasted years, so you can also run that, and then you get the rate for the forecasted years. So you can see that we have been able to forecast for from 2012, because the exact years ended at 2011. So we have been able to forecast the mortality rate up to, I think, 2026. So age 55 in 2026, this is going to be the mortality rate that we have. So that's interesting. You can subsequently extract all that you need in the function, or in the forecasted stuff. So you can call it again and then use $, and you have a lot of things to extract.